Hi everyone, welcome to this session. Uh, our topic is simple machines. To find our previous video, we are discussing about the inclined plane. So in this video, let's move on to the other simple machine, that is the screw jack. Uh, this screw jack will start with the structure of the screw jack. The screw jack, it consists of a cylinder with a spiral ridge runs around it. This spiral is called the thread, and the distance between the two adjacent threads is called the pitch of the screw. So that's how simply this screw jack how is structured. Now let's see the mechanical advantage, velocity ratio, and the efficiency of the screw jack. Starting with the mechanical advantage of the screw jack. Uh, Simply you can obtain the mechanical advantage of screw jack by taking the load upon the effort. That's the general formula for finding the mechanical advantage. So simply mechanical advantage of screw jack equals to load over effort. And when talking about the velocity of the screw jack, the velocity ratio is obtained as follows. Velocity ratio equals to distance moved by effort upon distance moved by load. Now, from there, we can see that the velocity ratio of the screw jack, when the handle of the screw jack is turned around, one cycle, the load is lifted a distance equal to one pitch. We talked about the meaning of the pitch in the previous slide. Now, in this case, the effort to move the distance equal to the circumference covered when the handle was turned. Now, due to this, the velocity of the screw jack will be obtained further as the circumference of the handle equals to 2 pi times radius, that is the length of the handle. So the circumference of the handle will be equal to 2 pi times L. Thus, the distance moved by the effort is equal to 2 pi L, and the distance moved by load equals to distance equal to one pitch of the screw. Therefore, the distance moved by load will be equal to P. Therefore, the velocity ratio from all those expressions, velocity ratio equals to 2 pi L over P. Now, let's see the efficiency of the screw jack. You can obtain the efficiency of the screw jack by generally taking the mechanical advantage of a velocity ratio times 100%. Now, let's see the screw jack in daily life. Here we'll see the various applications of the screw jack in our daily life. The screw jack are used to lift heavy loads despite the large friction they produce. The heavier the load, the higher the friction force. So simply the screw jacks are used just to lift the heavy loads despite of the large friction that can be produced from them. The other one that they are self-locking, meaning that when the applied force is removed, they do not rotate backwards. This Due to this case, they are used in adjusting the workplace chains, chairs and tables. So they are self-locking, meaning that when you apply some kind when the applied force that is when it was applied on them, they just do not rotate backwards in such a way that they are locked, you can't turn it back. So in that way, they can be used in adjusting the workplace chairs and the tables. The other one that they are also helpful in pulling and pushing machine equipments as well as tightening mechanical parts. So the screw jacks are very useful in pulling and pushing the various machine equipments as well as tightening the mechanical parts that can be found in the various equipments or in various uh, mechanical devices. So these are some of the applications of the screw jack in our daily life. So that's all I have for this session. We've talked about the screw jack. We've seen the simple structure of it. Then we've seen the mechanical advantage, the velocity and the efficiency of the screw jack, and we've finished up discussing the applications of the screw jack in our daily life. Hope that's all clear, and thank you.